Just to, before Maria, you start, let me just make a very, very short introduction to introduce you Maria Himonopoulou, who is working at the hydrobiological station of Pella. And she's going to present you the last two principles of ocean literacy, which is the 6th and the 7th. Maria has been working in the past as a teacher at secondary school, so she knows a lot about education, and she was at your position, and now she's working in a government, let's say, organization dealing with inland waters. So I think that, Maria, you can start.
Okay, thank you, Yolanda. So I'm going to talk to you about Principle 6 that reads as the ocean and humans are inextricably interconnected. Inextricably is an unusual adverb that means in a way that is impossible to separate. Is it impossible to separate the ocean and humans? Yes, it is, and today together we're going to find out why. The ocean supplies fresh water. Most of the rain that feeds our streams and rivers originate from the ocean. This means that most of the water we drink, most of the water we use to irrigate our fields, most of the water we use to produce marine photosynthetic organisms as seaweeds, tiny phytoplankton, seagrasses produce via photosynthesis half of the Earth's oxygen. I think that the chemical equation of photosynthesis is the most important chemical equation on the planet, and should be the base for many Blue School projects and environmental activities. In this slide, you can see an artwork produced by students a few days after I organized an EMD activity about marine photosynthetic organisms. You can see that the teachers and the students realized that seaweeds are present only on rocky bottoms, while seagrasses have roots, therefore are present only on sandy bottoms. And they have also realized that there are three kinds of seaweeds: the red, the green, and the brown ones. The ocean provides food. In this fire diagram, you see that in 2020, about 80 million tons of marine animals were captured, while about 33 million tons of marine animals were cultivated by aquaculture, were produced or raised by aquaculture. And when I say marine animals, I don't just mean fish, but I also mean mollusks, crustaceans, and other marine animals. Additionally, in 2022, 36 million tons of algae were produced mainly by marine aquaculture. The ocean provides medicines. Many marine organisms are potential sources of bioactive compounds with anti-inflammatory, anti-cancer, and antimicrobial properties. Cytarabine was the first chemical compound derived by a Caribbean sponge that was used to treat leukemia. And in the photo on the left, you can see a marine snail from the venom of which a chemical compound that is used as a painkiller have been produced. And this painkiller, it's much stronger than morphine, but without producing any tolerance. The ocean provides mineral and energy resources. Sand, gravel, oil, and gas have been extracted from the ocean by human minerals that are carried out by rivers to the sea as diamonds, tin, titanium, gold, and they can be mined by the shallow shelves of many coasts around the Earth. Of course, there are other minerals less known that are present in the deep sea bottom as manganese nodules, cobalt crust, and massive sulfides. The ocean is also a source of renewable energy. The renewable ocean energy industry is an evolving industry that uses devices, as you can see in this picture, that turn the energy from moving water and wind into electricity. The ocean supports jobs and national economies. More than 3 billion people rely on the ocean for their livelihoods. Ocean-based industries as tourism and fisheries are key sources for income, foreign exchange, and jobs. The ocean serves as a highway for transportation of goods and people. Maritime transport accounts for roughly about 80% of international trade. This means that most of our goods are being transported by ships. In this diagram, you can see that into 2022, maritime passenger transport reached about 350 million passengers in the EU ports. Imagine the number in the whole world. The ocean is a source of inspiration, recreation, rejuvenation, and discovery. I think I don't have to explain that. We all understand it and can feel it. It is also an important element in the heritage of many cultures. In the photo on the left, you can see a recreation of Pavlo Petri off the shore of Laconia, South Greece, which is the oldest known submerged city in the world that was inhabited since 3500 BC. And on the right, you can see a beautiful artwork produced by students 10 to 11 years of age for a project, a Blue School project titled Our Ocean, Marine Legends, Fairy Tales and Folklore in Ireland. Although the ocean is so important to humans and to all living systems on Earth, is in trouble. Why is the ocean in trouble? The ocean is in trouble because humans affect it in a variety of ways. We're causing many pressures. We apply many pressures to the ocean. And in the next slides, I will try to get into most of them. Overfishing. What is overfishing? Overfishing is when we fish too many fish. There are not enough adults left to breed and therefore sustain a healthy population. In this fire diagram, you see that the fraction of overfished stocks in 1974 was about 10%. But the fraction of overfished stocks in 2019 multiplied 4 times and is about 40%. The collapse of fish stocks will be devastating for coastal communities that rely on fishing, and there will be a problem of food security in the future. Some scientists say that if we keep fishing the way we do, in about 30 years, there won't be many fish left in the sea. As fisheries, tourism have expanded without sufficient consideration for environmental and social sustainability, leading to environmental degradation. The number of tourists exceeds the carrying capacity of a coastal ecosystem. And when I say the carrying capacity, I mean the number of organisms that an ecosystem can sustain without collapsing. So when the number of tourists exceeds the carrying capacity of a coastal ecosystem, environmental quality decreases. And when environmental quality decreases, then the touristic attractiveness of a certain area decreases too. Human development and activity leads to pollution. Marine and coastal pollution can be linked to the presence of litter, nutrients, organic matter, oil, and other pollutants as PCBs. Each year, billions of pounds of litter and other pollutants enter the ocean. The most famous marine waste is plastic, and the most abundant one. On the left, you can see a picture where plastic bottles travel. They end up to the river, and they're carried out by the river to the sea. Plastic bottles is something is a waste that we can see with our own eyes. What we cannot see is the microfibers that come from our synthetic clothes when we wash them. They end up to the river, and by the river they're carried out to the sea, and their amount is their total amount is not at all negligible. On the right, you can see a lost and abandoned fishing net. Lost and abandoned fishing gear is responsible for large plastic pollution in the ocean. Unfortunately, many marine animals, as turtles, whales, birds, get entangled in lost and abandoned fishing nets, and they consequently suffer. These are the size ranges of plastic debris that can be found in the ocean. Many marine animals mistaken plastics as food and eat it with severe consequences on their health and their life. Microplastics, some microplastics and nanoplastics can be ingested by primary consumers as zooplankton. Zooplankton are tiny little creatures that look like shrimps. And when microplastics or nanoplastics are being injected by zooplankton, they enter the food chain and they end up to secondary consumers as fish and top predators as humans. An inspiration for a Blue School project about plastics. There are many Blue School projects and environmental activities about plastics. This one is titled Plastic Pirates Go Europe. It is a citizen science project that is about the distribution and abundance of plastic waste in European freshwater systems. Nutrients, pollution produced by nutrients. Nutrients come from the agricultural runoff, basically fertilizers, and sewers that originate from our sinks and our bathrooms. So nutrients are carried out by rivers to the ocean and cause eutrophication and harmful algal blooms. What are algal blooms? Algal blooms is a phenomenon where certain microalgae species, tiny marine photosynthetic organisms, increase their numbers enormously. Some of them produce toxins that are dangerous to marine animals and humans. That is why certain algal blooms are named harmful algal blooms. Human development and activity leads also to oil pollution. When the oil spill may be small, for example, when a ship is refueling, but it may be big, for example, when an accident happens, as the one it happened in the Gulf of Mexico in 2010. And when the oil spill is huge, the consequences on the ecosystems and coastal communities are devastating and can be felt for decades. Also, most of the people don't realize that a very significant amount of oil residue end up from storm drains to the river and eventually to the ocean. And that amount of oil is not at all negligible. Human development and activity also leads up to noise pollution. Marine traffic, marine renewable energy projects, oil platforms, seismic surveys cause severe noise pollution in the ocean, and this affects very much marine mammals. In 2023, I organized an EFD activity about echolocation and ocean noise. The children had their eyes covered. One of the children was the dolphin, and the rest of the children were the fish. The fish had to clap their hands so that the dolphin could hear them and catch them. We repeated the same procedure, but the second time, the radio was on very loudly, and their teacher played the trumpet. So we did that in order for the children to realize that when there is too much noise in the ocean, marine mammals cannot find their food easily. Human development leads to physical modifications to beaches, shores, and rivers. Seawater movements as waves and they cause erosion. We don't like that as humans. We don't like erosion. So we build robust structures in the shoreline to prevent it. But sometimes, as you can see on the right, on the photo, in the pictures on the right, but sometimes over time, these robust structures can speed up the loss of coastal habitats. We built dams in rivers. The big dams are mostly created for producing hydroelectricity, a renewable type of energy. But dams also cause environmental impacts. They reduce the amount of sediments that end up at river deltas, which is something that leads to the degradation of deltaic ecosystems. For example, the deltas are being eroded, is being minimized, and the abundance of fish also decreases. And also, the rivers are being fragmented, which means that migratory fish as salmon and eels cannot travel upstream. And not only migratory fish, but other fish species as well. Artificial lakes that are being created by dams in rivers emit methane, which is a greenhouse gas 23 times more powerful than CO2. So here on the right, you see pictures of the delta of the Eloi River in the US. The first picture is taken in August of 2011. You see how small is the surface of the delta. And this is the last picture taken in July of 2017. After the removal of two huge dams in the Eloi River, you can see it's obvious how much the surface of the delta has expanded, and according to scientists, this was very, very good, influenced very positively coastal ecosystems. Another inspiration for a Blue School project connecting freshwater habitats, ecosystems, and marine ecosystems, titled Hydroelectricity. How much environmental friendly is it? It was under the umbrella of the Fish Migration Day, organized by the World Fish Migration Foundation. So what I basically did is to try and make students and teachers realize that, okay, hydroelectric power is a renewable type of energy, but it also affects the environment, it impacts the environment, and that is why there are no eels anymore in our rivers. Since the big dams were created, eels cannot travel upstream, they cannot travel from the sea upstream. Some more photos for the activity and a short description of its structure. We have also had a live meeting with Pau Fernandez Garrido, who is an engineer, and she talked to us about freeing rivers from obsolete barriers that are not being used anymore, which in fact are too many all around Europe. And the demolishing of these barriers is funded by the EU. Humans have removed most of the large vertebrates, as whales, large fish, sharks, from the ocean. And many, many species of bony fish, sharks, and whales are in the verge of extinction. Human development and activity also leads to changes to ocean chemistry and temperature. The atmospheric levels of CO2 are about 50% above pre-industrial levels. 23% of annual CO2 emissions are being absorbed by the ocean, which leads to the pH acidity. The ocean has also absorbed more than 90% of the excess heat in the climate system. So on the left, you can see a picture of coral bleaching. It's the white part. Is the dead part of the coral, and on the right, you can see how you can see some severe abrasions on the cell of a marine sail, which lives in a marine habitat with an increased pH. This can be linked very well to teaching pH in secondary school. Alien species or invasive species are species that are occurring in a certain area where they shouldn't be occurring, or where they shouldn't be occurring. So these species are being transferred by various means. There are vectors under human interference, as fisheries or ornamental species, ship transportation, etc. I want you to keep in mind that these are not only fish species, but there are also marine photosynthetic organisms as seaweeds, mollusks, and other marine organisms as well. In this map, the darker red shades indicate the greater number of species of alien species with a high impact on the local ecology. You can see that in the East Mediterranean, we are dark red. In the next slide, you can see a very interesting Blue School project about spotting the non-indigenous Portunus egnis, which is a crab species that entered the Eastern Mediterranean Sea by the Suez Canal. Much of the world's population lives in coastal areas, so many coastal regions are susceptible to natural hazards as tsunamis, hurricanes, cyclones, and sea level change. According to NOAA, sea level rise is the #1 natural hazard right now. And it is very important for us humans to build hazard resilient communities in order to avoid the big consequences of natural hazards that happen around the world.
Maria, a couple of minutes, please.
Yes, thank you, Thanos. So everyone is responsible for caring for the ocean. The ocean sustains life on Earth, and humans must live in ways that sustain it. Therefore, individual and collective actions are needed to effectively manage ocean resources. That is why basically Principle 6 is inextricably connected to SDGs 14, Life Below Water, and SDG 6, Clean Water and Sanitation. It is also connected to EU priorities, EU mission, and UN Decade 2021-2030. And here is a conceptual follow diagram for grades 3 to 5 for Principle 6. I know it looks scary. It's made for the US educational system, but believe me, it is helpful. So I hope during my presentation that I have demonstrated that we are indeed inextricably interconnected with the ocean. And I thank you so much for your attention.